Assalamualaikum dear students. So we were learning about the force on charge q naught due to the ring of charges. So whenever we have a ring of charges and we want to calculate the force z distance from the center of ring at this location, a q naught is placed. So we here consider a case of linear charge density, means the ring is one dimensional and this section small contains dq charge, and the length of this small section is r d theta, and the radius of ring is r, and this whole place is empty. So this is distance z and this is r distance from this section of the ring. So if we can calculate the force due to this section on this charge q naught, then we can integrate to find the total force. And here there is problem of symmetry, means this section of the ring will also exert same force. So this section will also exert force, that df will be in this direction, and this df will have also component. So this component will be in this direction and this component will be in this direction. So these two components are in opposite direction. These two components will be cancelled. Only the component that will be added, all components that is along the z axis will be added. So total force that is along z axis will be added. So total force will be along the z direction. So total force will integrate. So small, before solving this integration over dfz, we must find what is the small dfz. So small force that is along the dfz will be equal to k q naught and a dq, and a angle will be cos theta, because this component is cos theta. This component is cos theta. So this dfz q naught over r square. So first we find the value of r square from this triangle, because this is angle theta, and if we want to find the value of r square, that will be equal to z square plus r square, this r square. So r square will be equal to z square plus r square, and what will be the value of cos theta? Cos theta will be equal to this distance divided by this distance, base over hypotenuse. So this will be equal to z over r, and the value of r will be equal to under root z square plus r square, because r square is equal to z square plus r square. So now we will put all these values in this formula. We will put r square's value here and cosine theta value here. Our cosine theta also can be written as z over, because value of r is under root z square plus r square. So we will put all these values in this formula. So df z will be equal to k q naught, and the value of dq is equal to lambda, and you know that dq is equal to lambda into dl, or lambda r d theta. So d theta, and a value of r square. R square is equal to z square plus r square, and the value of cos theta is equal to z over under root z square plus r square. So if we solve that, simplify, that will be equal to k q naught lambda r and z square plus r square whole power, because under root is equal to 1 over 2, and that will become 3 by 2, and there will be z. If we keep z here, here will be d theta. Okay, so these all values are constant. K is constant, q naught is constant, charge, point charge, that is test charge, and linear charge density is constant, or the radius of the ring is constant, and z, the distance where we want to find the force on charge, is also constant. Only the variable that here theta is varying with the time, so with the ring, so d theta is varying. So we will take integration of this to find the total force of this whole ring. We will take integration of this with respect to d theta. So total force along the fz z will be equal to k q naught lambda r z over z square plus r square over 3 by 2 and d theta, and these all values are constant. So take out of these integration, so that will be k q naught lambda r z over z square plus r square whole power 3 by 2, and take integration of 3. And we will take integration because the total ring is from 0 to 2 pi, so limits will be from 0 to 2 pi. So this will become k q naught lambda r z over z square plus r square whole power 3 by 2, and this will become 2 pi. So if we say that the total charge on the ring is 2 pi r into 2 pi, if we consider, because total charge will be the total circumference of the charge or ring multiplied by the total angle of the ring, 2 pi. This is 2 pi. So that will be, if we replace that with by q, then the expression will be equal to k q naught q z over z square plus r square 3 by 2. So now if we take z as a 0, for example z equal to 0, then the force will be equal to 0. Fz will be equal to 0, because the when you decrease this distance z at this, you place this q naught here at the center, then there will be no force on the ring, because force from this section of ring will be in this direction, and the force from this ring will be in this direction. So all forces will sum to 0. Forces will be equal to 0. And if we take a case when z is very large than r. For example, if we take case where z is very small, greater than r of the ring, radius of the ring, means ring is very small as compared to z. In that case, our r will be in negligible, so the electric field will be equal to, sorry, force will be equal to F z will be equal to k q and q naught over z square. That is field due to the point charge. Means if you go very far away from the ring, then ring will appear as a point charge. So this is the field due to point charge. Point charge. Point charge.